Good morning again, grade 12. Welcome back. We continue with the functions. It's still me, Gabriel. Today I have chosen to do at least three functions: hyperbolas, logarithms, and parabolas. So we will do problems that are similar to those that you do in your past examination. For starters, I just want you to try this for yourself. You can actually take this down, and I will show the solution for only the first part, and for other parts you should be able to do that on. So you need to reflect f of x equaling to 4 divided by x plus 2 plus 3 across the vertical asymptotes. And the second one is find the inverse of f of x equals to 2 the logarithm of x minus 5 to the base 3. And the third one is find the quadratic function with the following x-intercepts or zeros, 1, 0, minus 2, 0, and this goes through the point 2 and 8. You need to explain your work in all you do. These problems are just to help you to start thinking about this, and also to give you some strategies, particularly in your exam, where most of these concepts will be actually questioned, and you need to revise that. Okay. Now, this is the question that I will explore. I will give you some few minutes to look into it. If you can look at the side here. If you look at the side, I have 1 minute this question here. So if I can read the question, it's sketched below along the side is the graph of f of x equaling to a divided by x plus p plus q, having the domain minus infinity and 1, union 1 and infinity. The graph of f cuts the y-axis at 0 and 5, and 0 and minus 5 at that point there. Now a line of symmetry of f is given by g of x equals to x minus 1. Now the questions are write down the value of p, and this is worth 1 mark. So I have that time there, 30 seconds, and determine the equation of the horizontal asymptote of f, calculate the value of a, our parameter here, and for which value or values of x is our function negative or less or equal to 0. Now, the graph of f undergoes a transformation to h, where the domain and range of h are the same as that of the function f. The derivative, that is h prime of f, the derivative of h is positive on its domain. Now we need to describe a possible transformation that f could have undergone to result in h, and that is worth 2 marks and therefore 2 minutes. So the whole question is about 10 minutes. We'll give you just a moment to see if you can figure it out. And I think maybe if you can just go half of that, even if you don't complete all the questions. The idea, if we remember in our last lesson, we did discuss how you have to optimize your time, that is time management, when you're writing the exam. So questions like those which worth 1 mark, and I actually should be able to do them quickly. But if you find that you spend a lot of time, if, for an example, on this question, you're going to spend more than 2 minutes, then you need to look at other questions that you can actually do quickly. But the important thing is when you receive your question paper, please read it fully. Also, familiarize yourself with the formulas that are given at the end of the paper. Okay. So far, I think by now, you might have already attempted some of the questions. You might have written down the value of P, and you could, those who are spots, you could have also figured out the asymptotes, because again, you are given the graph. I hope it is visible, and you can read other information from the graph in order to answer these questions. Somewhere you'll have to do some working like finding the value of A. Right, even if you did not figure out everything, I will actually, continue so that we do it, and I'll try to explain it step by step. Okay, I think you might have done it. Even if you did not, as I've explained all the questions, it's fine, but you need to be aware of those that you could not figure out as you are looking at the problem as it is. Okay, let's go to the solution. Now we are given the function f of x and with this domain. Now, what's the meaning of this domain? It means 1 is excluded in our domain. So our x cannot be 1, but it's all the values that are less than 1, excluding 1, and all the values that are greater than 1. That's the domain of our function. So you can actually see it again here on the graph. So obviously now they have given you something. So we can actually see this. If you know the terminology, you can start identifying what is that line representing. And so here's our 1. So in terms of the domain, it is that side, excluding that 1, and also all the values that goes there. Now, we are also told that the graph cuts the y-axis at 0 and -5. So what does this mean? This means we have our y-intercept, or the y-intercept, which is 0 and -5. And also our function has a line of symmetry, g, which is -x -1. So yes, it's slanting downward. It means because our gradient is negative for that line. And you could actually notice also from our graph here that we have another line. You can on your own, find the equation of that line. But I want you to also notice this point M. What is actually common about that, about this line. So from our equation, remember, immediately when they've given you like that, like f of x equals to a divided by x plus b plus q, then it means at first you will need to find those, that question is going to come, that you need to find those values of those of a, p, and q. Okay, so for a function of the form a divided by x minus h plus k, we have our vertical asymptote as x equals to h, where h is excluded from the domain, and we have our horizontal asymptote as y is equals to k. Now, our h is excluded from the domain, and our horizontal asymptote is y is equals to k. So I need you to pay particular attention, particularly to signs. And also, I just want to bring this to you that here we are talking about the function of the form a divided by x minus h plus k. Now, look at how it is written from this function f of x equal to a divided by x plus p. Here we have x minus h and plus q. So they are both hyperbolic functions. Here we are using this in order to answer, to understand that function. So you will also notice, if you also recall previously, how we define our horizontal asymptote. Now, the center of this hyperbola, function is h, is given by that point h and k. So you can start to think with our given question how we are going to try to answer it. Now, let us find the value of p. So domain excludes x equaling to 1. So vertical asymptote is x equals to 1. I want you to pay attention to that. The domain excludes x equaling to 1. Therefore, our vertical asymptote is x equals to 1. Now, in f of x equal to a divided by x plus p plus q, the vertical asymptote is x equals to minus p. And where does this come from? If we're given this function, to find the vertical asymptote, we set the denominator in this function, this, to be equaling to 0. But since we are now looking for that, we understood in our previous slide that given a function in this form, earlier we said x minus h, and here we say x plus p. Now, to determine our vertical asymptote, x equals to p. That will be our vertical asymptote. Okay, but remember, for our denominator, x must not be equal to p. That is quite because if x equals to p, this is going to be divided by 0. But when we define the vertical asymptote, we look at the denominator only, so that it will tell us, when we look at the whole thing, what is going to be avoided there. We always avoid division by 0. So our vertical asymptote is x equals to minus p. Therefore, minus p equals to 1, implying p equals to minus 1. Now, we go for the horizontal asymptote. We notice that our symmetry line, y is equals to minus x minus 1, passes through the center, hk. Since h equals to 1, we substitute into this equation in order to determine the value of y. So when we substitute h equaling to 1 there, we find the value of y to be minus 2, which is our horizontal asymptote, y equals to minus 2. Now, determining the value of a. So we were also given that the y-intercept being 0 and -5. So if we substitute that into our equation, something which I want to explain as we move on. Sure if I'll be able to write. So remember our f of x equals to usually I don't use this pen. A divided by, we have found the value of p, x. We found our p to be -1, I think it's x -1, and we found our horizontal asymptote to be -2. Okay, I don't have a pen that will write better, but just to keep you in the loop, this is the function that we're working on. So now using this y-intercept, we are looking for the value of, in order to find that, we substitute the derivative f of 0, which is equals to -5, and we result into that equation a divided by 0 -1 plus -2, which simplifies to, here we're going to get a divided by -1, so we'll be having -a -2, and then we solve for a. Therefore, we found our a equal to 3, and eventually our function f of x equals to 3 divided by x -1 -2. Okay, so far we have done from our given problem, number 1, number 2, and number 3, we have found the value of p. We have found the value of the horizontal asymptote, and we have found the value of a. And our horizontal asymptote, you can actually see it is -2. Our vertical asymptote, remember, we said x -1 equaling to 0. Therefore, x equal to 1 is the equation of our vertical asymptote. If I may go back a bit to the function, so that at least we are not lost. So this is what we were given. In fact, if we may start the question. So far we have done up to number 3 then. We have found the value of p. The question says just write it down and you quickly. But as I'm doing it such that you understand where does the value of p come from. This is just like revising. So, and we did determine the equation of the asymptote, and we found it to be -2, and we have calculated now the value of a, and this is where we are. If you do have questions, you can write them in the chat. When the video stops, we'll actually have I will have attended to them and you can discuss that further. So this is now our function. Okay, let's move on. Now, they want us to find when is our function less than 0 or equal to 0. Now we'll also try to show it on the graph that we are given. Okay, now here's our graph. Let us try and understand what our question is. They want us to find where our function f of x is less or equal to 0. So we know the y-axis and the x-axis on our Cartesian. So anything above the x-axis, when we read it as our function, it is positive, and what is below the x-axis on our y values there, our function is negative. So by looking at our graph, you can also simply tell where our function, possibly it is actually negative. So we see here from there our function going up there is positive because it lies on above the x-axis, meaning on the positive. So all the values of the function, when you read them there, you'll all be reading negative positive values. But also there, from that point on the x-axis, we see our function is 0 there. So ideally, for where it is 0, then we know that we need to set our function there to be 0 and solve for x in order to find the value of x there. And from there, when you go there below, all these values, this continuous, are below the function, and also this other part is on the negative values. But mind you, the question is, when is f of x less? So meaning we need to find the values of x such that our function is always, it's either 0 or always negative. Yeah, by the way, negative is less than 0. Positive is greater than 0. Okay. Now, recall our function 3 divided by x minus 1 minus 2. So we want the whole function, our f of x equals to that. We want that to be less or equal to 0. Okay, implying now when we add the additive inverse of 2 there on both sides, we add the additive inverse of minus 2, which is plus 2. So here is going to be 0 plus 2. So minus 2 plus 2 is going to be 0, therefore it will disappear. Then we're ending up with 3 divided by x equal to minus 2. Okay, under normal circumstances, in order to find the zeros, people will be tempted to cross multiply them. Okay, but this is the direction that you are going to take, and there is a reason, for that, because it is quite simple to tell when the function is 0, other than when it is a number, because now it means we'll have to search in Phoenix. So to find the zeros, we still retain this function, we write it as it is, and we equate it to 0. So we will simplify this to be there. In other words, we multiply this by x minus 1 and divide by x minus 1 to make this to be the same fraction, so that we can add, subtract them. So if there will be those that might be lost, what I meant, I was attempting to simplify this here, so my pen is not working. Okay, we simplify to this. You can see we will be able to take this backward if we want. I wish if I had another pen. Let us look at this minus 2x plus 5 divided by x minus 1. We want the whole function to be 0, and this will be 0 only and only if our numerator is 0. We don't worry about the denominator. We want our numerator to be 0. Hence, that is why we provide this. Now, we avoid also cross multiplying, because when you cross multiply, we might find a value that might be equaling to 1. Therefore, without loss of generality or to avoid such, we analyze this and then we do what is important. We test the intervals, checking the signs. What will this how we will find those values, or all the values that will give us our function to be less than 0. So we then start to check all the values where x is greater than 5/2. Now, 5/2 or 5 divided by 2, it is actually that value where our function crosses the x-axis, and it avoids x equaling to 1 is our vertical asymptote. Our function approaches but never cross. So we check all the values that are greater than x values that are greater than 5/2. So the first value, we can just check because 5/2 is the same as 2.5. In other words, it is 2 is and a half. So any value that is greater than 2 and a half, in other words, if you write it in decimal form, it will be 2.5. So any value that is greater than 2.5, 2.6, 3, then we substitute it in our function to see what is going to be the sign of our answer when we substitute, or the sign of our function value there when we substitute this x value. But we can also see our 3 is beyond on the positive x-axis. It's beyond that, and we can see that our function is negative. So we take all the values that are greater than half. Our function will be zero, will be negative. We continue. We look at the function that are, remember, we're excluding 1, greater than 1, but also excluding less than 5 halves. So between 1, remember 2 and 5 halves is 2.5 or 2.5. And so any value that is less than 5 halves but greater than 1, what does it? So you can actually see this is the values between 1 and where our function cuts the x-axis. So we can actually see that that part of the graph is above the x-axis, and so it is on. But then we can also even see when we calculate the function when x equals to 2, we will find our function to be 1. Okay, for an example, 2 minus 1 then is 1. So we're going to have 3 minus 2, which is positive 1. And positive 1 is never less than 0, but it is greater. So we exclude, we discard those values. And then we check again all the values that are less than 1. But we can see from our graph that all those values that are less than 1, going even to the negative x values, we will find our function to be negative. But from our function, we can actually read that. So when you're writing an exam, in actual fact, these are something that you just write straight. If you read f of x less than 0, you can actually see that part, it is less than 0. So you look from the domain there, where does that start? Okay, and also from the, so that is why they say write down, and sometimes they might say show algebraically, which is what we have done. But you look at the marks might never want to. But the important thing, if you did do the test and like, it shows your understanding, and the marker will allocate you some marks. Again, if there's something that you actually not show off or you are unhappy about, please write it in the chat. Otherwise, we'll be discussing it when the video stops. Okay, now therefore our values, it is all the values from 1, excluding 1, up to the negative values of x, and all the values that are greater than or equals to 5 halves. Now look at the brackets. Here we have curly brackets because minus infinity we don't know, and it's also excluded because it goes on and on. 1 is excluded, it does not form part of this, therefore, because we're looking at all values that are less than that, but not. But 5 halves, because here they say f of x less or equaling to 0. We have shown that our function equals to 0 when our x equals to 5 halves. So that is why we have a square bracket there, which shows that it is equal to. And this can be written also in another way. It's a pity that my pen is not user-friendly here working. Because others can, yeah. All right, let me try with this one. I don't like writing with this one. Can say x is less than 1, and also x is either greater, depending on where you write it, greater or equal to 5,000. You can, it is acceptable how you have written it if you don't want to write it in set form like the one I've written. Okay, so we have answered number 4. Now we go to the last question, the transformation. Most of these questions in our exam, they come with the transformations, and sometimes in most cases they carry a lot of marks, and so understanding them it's important. Now we need to transform our f of x, must undergo transformation to h. So these are the requirements. The domain of h must be the same. The domain and range of h must be the same domain and range as f. Remember, h is a transformed function, and when we take the derivative of the domain, it must always be positive. When we take the derivative of the function, so it must always be positive in its domain. For all values of x, the function that we get when we derive h will always be positive. Now, to transform a decreasing function, f of x, into an increasing function, h of x, while preserving its asymptotes, we can reflect it vertically across its horizontal asymptote. This reflection will invert the function's behavior while keeping the asymptote in place. Mathematically reflecting across the line y equals to c transforms a function m of x equaling to 2c minus m of x. In this case, we have f of x. So, and we are reflecting across. We are reflecting across the line y equals to minus 2. Remember, our f of x I don't know if I still have it. Our function f of, you'll pardon me, I'm trying to be very much artistic here, equals to this is what we determine, 3 divided by x minus 1 minus 2. So our horizontal asymptote, in this case, it is y equals to minus 2. So we are reflecting, to find h of x, we reflect across that line y equals to minus 2. So that reflection we have shown is this will be, in order to find h, reflecting it across y equals to minus 2 results in 2 times minus 2 minus f of x. We know our f of x. So this is going to be equal to minus 4 minus f of x. So hence we have minus 4 minus 3 divided by x minus 1 plus 2. And simplifying that further gives us our h of x equals to minus 3 divided by x minus 1 minus 2. I hope I have that function somewhere, and the derivative of that, I just want to So this will be, so when you find the derivative here of this function, this is going to be 3 divided by x minus 1 all squared, because we are squaring that denominator there. So except when x must always not be 1. So for any value of x except when x equals to 1 that we substitute there, we will always have a positive value, even when we look into I just wanted to demonstrate this. I should have it ready, but when we discuss after the video stopped, I will show you using decimals what does this means, and also looking into that reflection of the function h of x. How does it look like? And you will actually see other interesting properties in mathematics when you reflect, whereby you still retain, the domain and range, what actually happens, where the other parts of this, they just swap around. The other one which was below goes above, and the other one goes below. Okay. Please, if you've got some questions, keep on writing them on the charts, and so that we can discuss them further. And when we discuss them, as promised, I will use a demonstration through decimals so that you can see live the transformation of h. So if I may just recall a bit, the important statement here is to transform a decreasing function f of x into an increasing function. I think it will be justice to show you what we mean by a decreasing function. And to do this quickly, I have to, we are looking at equals to 3 divided by x minus 1 minus 2. So if you are looking at this, you can actually see this is the function, and we actually know that our horizontal asymptote y equals to minus 2. It is that line from our function. So we are transforming this to h. This is f of x as it is. We are transforming, but remember also this our domain, so that is a vertical asymptote. So we found our function h. We said we transform it vertically above that line, y equals to 2. So what this means is that we found it was simply y equals to 3 divided by x minus 2. Now you can actually see domain and range remains the same, and also the asymptotes remains the same. But now this is the transformed, this purple, I think, I don't know the name of the colors. The purple color is the transformed equation H. Now you can actually see that tail there on this. Initially it was in the first and third quadrant, but now the transformed function, we find our graphs, to be on the second and fourth quadrant. So it was just simply a minus. Now, this, what we have thrown here, shows those two conditions. The first condition, that the domain and range must be the same. But now they said the derivative of our H must always be positive in the domain of H. So when we take the derivative of that, we can actually, let me see if, but well, I know that that derivative equals to 3 divided by x minus 1 squared. Now look at that, the black one, that is the h prime of x. So you can actually see it is always above x-axis. These are x-axis, so the derivative function is always positive in the domain of x. Okay, that was on an aside, which I wanted to demonstrate quickly. Because now I'm okay. Right, as I've explained before, we will discuss this if you've got some questions. This was the actual transformation that we did. So and to meet conclusion, a possible transformation of f of x is actually the reflection across its horizontal asymptote, the line 1. So reflection, rotation, those are transformational terms. Right. Question B. Also, it is timed there. Question B, the question A, it involves the hyperbola, largely, and the straight line, a function which appeared as a form of line of symmetry, showing other important aspects regarding questions that you get for these functions. Now, question B focuses on an exponential graph, and we are being given the logarithmic, for starters. And when you look clearly there, you will see that we will need to find also a function h, which is the inverse of the function f, and that will be an exponential function that we normally know. Now, also you can actually see that I have given you times that you need to actually spend when solving these problems. And if you happen, like this one, it's 1 mark, you need to spend those in fact, not even 1.5 minutes of that. You need to spend less than that. so that you create a buffer, time management. This is quite crucial. And also, I still emphasize, look at, be aware what you are giving in your at the question paper, the formula sheet, and you need to be aware what is not given, so that at least for what you are not giving, you can simply start by writing it somewhere so that you can remember if you need to use that kind of information. Okay, I might give you 1 or 2 minutes to look into this problem. So in total, it is about, it's 4, it's 7, I think it's, plus 8, about 15 minutes, which you need to take about 7 or less to economize on time. Now you are given the function f of x equaling to the log of x plus 1 to the base a. For a positive, a must always be positive. In fact, a is positive, and also it cannot, can it be 1? Yes, it can be 1. Okay. But it must not be negative. And you will actually understand when you do exponential loss or even logarithmic loss. Like, for example, you can't raise a negative number to a power, because for exponential and logarithmic functions, you just need to understand your logarithmic loss. They are important. You can't make sense of them if you don't know your logarithmic laws, and also understanding the properties of a log or an exponent. Like, the logarithmic of 1 is always 0, and you don't have the log of a negative number. Any number raised to the power 0, it is always 1. So that is why our a must always be greater than 0. It cannot be equal to 0. So our first question here, we need to calculate the value of a. We need to write down the domain of f. We need to sketch the graph of f, clearly showing the intercepts on the x-axis and asymptotes. And also now we are given further that C is a point on H, where H is the inverse of F. And that point is at, it's at where y equals to 19 divided by 8. 19/8. But let us just say 19 divided by 8, or 2 comma something. Now we need to determine the coordinates of C. So we are at least given, I think, some y value there. Okay, I think you have interacted with this question. I think you have identified what you can do, what you can't do, and I think you have noted in your notes what the question is about, so that we can start solving it. I repeat again, if you've got some questions, please write them in the chat, and I will also give out my email address if there are things that you want to ask further. Suppose we don't cover them during our discussion, then you can also ask me through an email.
All right, so that's it, Gabriel.
Yeah. You advise me. Honestly speaking, you are the one that is going to edit. Whether I can, on my own, record question B, question C, and perhaps maybe to show them also question C.
Okay, yeah, that can work as well. I think it's a good idea.
Okay, then let me show them question C. Okay. Right. I don't know if it is visible, but this is question C. The videos for question B and question C will be available and for you to interact with. As I've explained, you can write to me through an email if you have further questions and you want to engage with that. We didn't have a chance. So question C, you are given the sketch which shows a parabola F and a straight line G. Intersecting in A there and F. The points C, minus half and 0 and E, 1 and 12 are on the parabola. Here is C, and immediately when they've given a minus half and 0, you must know that that's an intercept. And this is any point there, E, on the parabola. And you're also given P, 0, 2, you must know that that is a y-intercept for that straight line function, G. Okay, is a point on the line D. On the line D is the turning point of the parabola. So looking at the formula sheet, you should be able to work out something there. But yeah, unfortunately, if we look at the questions, you might not right away work out the coordinates of D. So if I may read the question again, the sketch shows a parabola F and a straight line G intersecting in A and F. So these points here are on the parabola and B, 0, 2 is a point on the line. D is the turning point of the parabola. The straight line makes an angle of 45 degrees with the x-axis. Okay? Quite important. Already, if you know your analytical geometry, you will understand what is happening, and you'll also deduce what will be the gradient for that line. Now the question is, give the defining equation of G. You will need to be very strategic in determining that, and you are being asked what are the coordinates of F. You are also being strategic. You are actually, if you know the equation of G, you should be able to determine the coordinates of F. And now give the defining equation of F in the form of y is equal to ax squared plus bx plus c. So there you have that root, the x-intercept there, and you will have determined the coordinates of F in number 2, and you should actually know how to work with that in order to find that. Remember the x-intercept, how you do, so you will have x plus half and whatever that you have for the thing, and then you need to determine through D a tangent is drawn to F, to the function. So if they say a tangent is drawn to F through D, and D is our turning point we are given, then it means that tangent must be parallel to the x-axis, you will know that gradient. What is the gradient of the tangent passing through D? Hence, that is why it is 1 mark. You will see it is a line that is horizontal, and you know the gradient of the horizontal line. And you can even also, using calculus, you can determine that. And they want also the coordinates of the point where the tangent and G intersect. When you draw, you don't need to actually draw them, but you can. So what they want the coordinates of the tangent where it is equal to that straight line. So you know 1 point here, that tangent will cross somewhere on the x-axis. On the coordinates, you know that, and therefore you simply substitute on that. So most of the parabola and straight line or questions, that's where you have to get most of the marks, because those ones are straightforward. Even though sometimes they might put in questions which require a bit of thinking, but it is easily. If you recall from the first our last lesson, I did show in terms of the parameters, how does the parameters affect your parabola, whether going up and down, changing the value of C there, and and concaving up, what usually happens. So understanding that, you should be able to answer most questions. Okay, this will be going up to this point.